Hello everyone. So today we are going to discuss about program partitioning and scheduling. So here we are going to discuss um, level of parallelism involved in the programming. So first we will discuss about um, grain sizes. So grain size, or it is also called as granularity, is a measure of amount of computation involved in the software process. So in a program, it is just a measure of the amount of computation involved, that is called as grain size. So the simplest measure is to count the number of instructions in the grain. Okay, so grain is nothing but you can take it as a program segment. Again, grain size can be uh, determined as a, so it can be determined the basic program segment chosen for parallel process. So again, it can be taken as a fine grain, medium grain, and a coarse grain. So depending on the size of the program segment we are choosing for parallel processing. So again, we are dividing it to fine grain, medium grain, and coarse grain. So this figure shows the levels of parallelism in program execution on modern computers. Here we have uh, 5 levels, and so level 1 and level 2, if you observe, it belongs to fine grain section, and level 3 and level 4 belongs to medium grain, and level 5 to level 4 it belongs to coarse grain. And at level 1 we have instructions and statements, and at level 2 we have non-recursive loops or unfolded iterations, and level 3 we have procedures, subroutines, tasks, or coroutines, and at level 4 we have subprograms, job steps, or related parts of the program, and level 5 we have a whole complete program. So first we will discuss about um, instruction level, that is level 1. And if you see here, level 1 and level 2, they come under the section fine grain. So at the lowest level, a typical grain contains less than less than 20 instructions. So it contains less than 20 instructions, called fine grain. So that's why it is called as a fine grain. And the exploitation of fine grain parallelism can be achieved with the help of optimized compiler, which should be automatically detect parallelism and translate the source code to the parallel form so that it can be executed by the runtime system. So here parallelism is done by optimized compiler, and usually the instructions are less than 20. So in that case we call it as a fine grain. So in level 2, it is also called as a loop level, and it corresponds to the iterative loop operations, and loop usually contains less than 500 statements within the loop. And so whenever there are less than 500 statements within a loop, then we are considering it as a fine grain, and we are trying to execute those instructions parallelly to reduce the execution speed. So in detail we will learn how to optimize the program in further coming modules. For time being, we are just because still we have not introduced with the pipelining, so how actually the program is executed parallelly. So we'll discuss as it is discussed in the further modules. So next is level 3. Level 3 we have procedures and subroutines and task. So this procedure, subroutine, task, and here it belongs to medium grain and it contains less than 2000 instructions. Okay, and it is very difficult to detect the parallelism at this level, and it can contain less than 2000 instructions. Then it is called as a medium grain. So next, at level 4 we have subprograms, um, job steps or related parts of the program, and at this level it may contains more than 2000 statements or thousands of statements, and usually parallelism is achieved by the algorithm designers or programmers, and it is not done by the compilers, as in the fine grain at level 1 and level 2. So it is handled by algorithm designers and programmers. So finally we have level 5, so jobs or programs. So whenever the program contains millions of instructions, so in that case again it is called as coarse grain, and it is very difficult to handle, and usually it is handled by program loader and by the operating system. So time sharing or space sharing multiprocessors explore at this level of parallelism. So basically if you see here, level 1 and level 2 belongs to fine grain, and level 3 and level 4 belongs to medium grain, and level 4 and level 5 belongs to coarse grain. And so usually at fine grain we have less than 20 instructions to 500 instructions, and if you come to the level number 3, so we have less than 2000 instructions, and at level 4 it may be greater than 2000 to several thousand instructions, but at level 5 we have millions of instructions to execute. And so this is usually handled by compiler, and level 4 and level 5 usually handled by the operating system as well as the programmers and algorithm designers. So so achieving parallelism is very difficult at the level 4 and level 5, and level 1 and level 2 it is very, compared to level 4 and 5 it is easy. Okay.